Hello, everyone. We will wait for some time so that people can join the meeting and we can start our discussion. As it's been more than 5 minutes since the class has started, so I guess people will join in the meanwhile. So, hello everyone. My name is Himanshi Singh, and today we're gonna discuss the week 5 assignment. Mostly, it will be previous year questions. So, as usual, we will go back to some of the basics of this week and we will revise some of the concepts which will help us in solving our current assignment. I hope that every one of you will be able to do it nicely, as I think your exams might be approaching for this particular subject. So, I thoroughly hope that every one of you is working hard in earning the certificate. So, let me just start sharing for our slides today. Uh, as I can see, Venkat is in the chat. Hi Venkat, can you just assure me that are you able to see my slides and I am audible to you? You can drop a yes in the chat box or you can unmute yourself. So I hope the answer is yes. So let's start with today's discussion. As you remember, in this week, we actually covered quite a bit. So I'm going to discuss this part of the module, which was basically energy production from waste plastics. So I guess every one of you is quite eager to know how we can generate energy from the plastic because it poses such a uh, daunting task to handle the plastic waste which we are generating on per day basis. So these are some of the methods or techniques which we can use to mitigate the waste generated by plastic. But again, these are not sufficient enough because the production rate is more than the consumption rate, meaning the amount of plastic which we are generating as a waste on daily basis is overpowering the techniques and the advancement in the field of using plastic, specifically in the field of generating energy from the plastic waste. So, if you remember, Professor Mandal has discussed quite a bit in this module. So, we will just go through it once again so that we can It will be helpful for plastic is a material consisting of any of a wide range of synthetic or semi-synthetic organic compounds that are malleable and can be modeled into solid objects. I hope that you know what malleable means. Malleable is you can give it a shape of anything which you desire. Even certain metals are malleable. I think you guys have an idea, like silver and gold. You can make jewelry out of it. You can make thin wires. So these metals are malleable in nature. Similarly, a plastic. So plastic is basically a material which is malleable and can be molded into any solid object. Plastics are typically organic polymers of high molecular mass, but they often contain other substances like fillers, plasticizers, and colorants, right? So fillers, basically what they do, fillers improve performance and reduce production costs. Second, plasticizers are oily compounds that confer improved rheology. Rheology is the ability of the material to flow. So if you're molding anything, right, which means you are melting it and then you are putting it in a mold. So that property or the property of a material to take the form of a mold, it has to flow. So the study of that is called rheology. Then last, colorants are common additives, although their weight contribution is small. We see variety of plastics around us, right? Green, white, blue, different shapes, different thickness, different composition. So all that property comes from these three compounds: fillers, plasticizers, and colorants. And as we know that we are not supposed to eat plastic, it is bad for your health, right? So that is one of the major reason for that, because the additives which are added in the plastics are toxic in nature. So plastics, especially which are derived from petrochemicals, they are partially neutral because partially natural, sorry, because they are derived from the natural sources, but still you should not eat them at the end of the day. So there are basically two different types of plastics. First one is thermoplastic and second one is thermosetting. So I hope that you guys are aware of these two types of plastic. So thermoplastic, they basically do not undergo any chemical change in their composition when heated and can be molded again and again, right? While thermosetting, as the name suggests, that it will set once you have put it in a mold or a shape once. You cannot bring this back to its natural occurring form because it has set in that mold or form. So thermosetting or thermoset can melt and take shape once after they have solidified, and then they stay solid. Irrespective whether you are increasing temperature, decreasing temperature, it won't lose its property. So we see variety of plastics around us almost every day. We do not even realize that what like we are literally surrounded by plastics, and everything which we are touching once in a day, it is made from plastic, right? So these are some of the common types of plastic and the examples, which means the plastic and the product which are formed from that plastic. You can easily find these symbols as you can see here in the slide. This is basically a recycling symbol. So in this 1, 2, 3, 4, these depend upon the type of plastic and the polymers. So the PET one, it is generally used in making beverage bottles, medicine jar, clothes, clothes, and carpet fibers, right? Because they are very thin and you can handle PET very well. HDPE is it is made for containers of milk. If you know, there are like thick plastic containers in which milk come, and even if you're not aware of such things and you have witnessed some of the movies, then you can see that these milk containers are present there. So these are like those translucent white milk containers. Motor oil, shampoos and conditioners, soap bottles, detergents, and bleaches. PVC, all kind of pipes and tiles, commonly found in plumbing pipes, as you can see in this image. Every one of us in our homes, in our institutes, in our organizations, PVC pipes are the pipes which are used for plumbing purposes because they are very durable and they can be molded easily in comparison to other polymers. LDPE is cling film, sandwich bags, squeezable bottles, and plastic grocery bags. Uh, These are basically very generally they are transparent in nature, but not always. So cling films are basically used for food products. For example, if you have a fruit or a leftover food, right? You generally wrap it around it so that no air can pass through it, and it will help increase the shelf life of the food. So cling films are those kind of films, and they are made from LDPE. PP, from PP you make lunch boxes, yogurt pots, which means they are very thick in nature, right? From the product type, you can, at least even if you do not know the monomers of these plastics, you can get what kind of a properties these polymers might be providing, right? Then PS, again, you can go through it, that they are made up of disposable coffee cups. I hope you have seen those Nescafe red coffee cups, right? They are paper cups at the end of the day, but there is a very thin covering of plastic inside the paper container, because at the end of the day, you are putting what? Water. So if you hold water for a long time in a paper cup, the paper will absorb the liquid and it will disintegrate. While if you are coating it with a thin plastic or a thing which is not permeable to water, the container's durability increases. And uh, uh, some other types of plastic which helps in making these products, right? So these are the monomers, and I know it might be a bit difficult for you to learn each monomer and name of plastic, but I would suggest you to at least give it a try, that you are able to learn the monomer unit of the protein, at least, because these monomers provide the property which we have talked above, right? So the property will allow us to make the products for our desired quality which we want. So try to remember the monomers of these common occurring plastics. For example, LDPE, which is like basically polyethylene, which is of low density. It has ethylene as a monomer. Monomer meaning, as I can see, I have few participants. I would like you all to just drop a message in the chat that where are you from and what you guys are doing, your background, or in which course you are enrolled in. Also, I would now like to have some active discussions if you guys are open to it. So what are polymers and monomers which I'm talking about here? Can anyone tell me? You can easily unmute yourself or just drop the answer in the chat box. Both are fine for me. So what are polymers and what are monomers? Firstly, give your introduction, please, in the chat box. I would like to know to whom I'm teaching. Hi, Himanshu. Thank you for your kind introduction. Others, please also just drop a single line introduction. I have to first know the introduction from everyone, then I will tell you from where I am. I will give my introduction. I gave my introduction in the beginning of the class, but none of you were there. So just drop a single line introduction. Guys, I'm asking for you from where you are. Hi, Divyam. Yeah, I remember. Thank you for your introduction, Divyam. And thank you for re-attending my class. I feel like no one is attending my class, and I'm a bad teacher. I'm fine. I think we should not waste any more time. Uh, in the meanwhile, you guys can just drop from where you are, what you guys are doing. And now you have to tell me the difference between polymer and monomer also, guys. Okay, so it feels like no one gonna answer me. So basically, polymers are the multiple units of a single commodity, right? That single commodity can be of same chemical nature. Here, for example, we can see that ethylene is a repeating unit, right? So if multiple ethylene units are connected one after the another, the extended joint monomer which is now formed will be called polymer, right? And polymers can be either homopolymer or heteropolymer. As the name suggests, that homopolymer will be made up of same single repeating unit, while heteropolymers, though they will be made from repeating units, but it is not necessary that those repeating units are same in nature, right? So I hope the difference is clear between the polymer and the monomer. So here you can see that the LDPE, the monomer is ethylene. For HDPE, it's ethylene again. For they will depend upon the type of saturation and the numbers which are connected to them, the number of monomers. Then polypropylene, polyvinyl chloride, PT, PETP, polystyrene, all these are, you have the monomers right here, right? Then what are the, again, these are continuation of it, but they have something different in it. As you can see, as I mentioned, that there can be different monomers also, right, in a polymer. So these are some of the examples of such polymers. For example, polycarbonate, right? It is made from the organic functional group, which are linked together. So I hope you guys know what is a carbonate group or carbonyl group. What is a carboxylic group? Okay, so carboxylic group is basically, if you remember in your basic chemistry classes, the carboxylic is a functional group which is often denoted by COOS. Yes, correct. So ABS, it has acrylonitrile, butadiene, and styrene as a monomeric repeating units. Correct? So what at the end of the day, what we are concerned with? We are concerned with how at the end of the day we can get the best energy production from the plastic which we have, because we have abundant plastic. But are all the types of plastic will be a good source of energy? What do you guys think? My statement is we have abundant plastic around us. So why there is so much chaos that we need to manage plastic waste? We can directly make energy from the plastic waste, right? So it won't be waste anymore, it will be a useful waste. This means that every plastic is a good energy source. So, do you guys agree with this statement or disagree with this statement? Those who agree can just give a thumbs up, and those who don't, just don't do anything. My statement is we can generate energy from plastic, right? So why we have plastic management crisis if we make energy from from a raw material, right? So we should do it. We should not have issues in handling the raw material. And here, raw material is the plastic. So those who agree that every plastic is suitable for energy production and hence we don't have any plastic management crisis, give a thumbs up. And those who deny with this statement, give a thumbs down if such thing exists, or just type no in the chat box. Okay, I got one thumbs up. something in the chat also. Okay. Okay, till now the response is 50-50%. 50%. Okay. So see, though we can generate energy from every plastic, but the amount of energy generated from the plastic should be sufficient enough, right? Because if you remember, till now we have discussed so many processes through which we can generate energy, right? Thermochemical pathway, biochemical pathway, chemical pathway. So all of them require at the end of the day some input of the energy for running the process. So you will run a process only when it is profitable to you. And here the profit is not related to the money. The profit is related to the product. So if you're putting 10 units of energy to make a product which holds the energy value of 2 units, you will face losses, right? Because you are giving so much input, but at the end of the day, or the output is very low. So you should always aim for maximizing your efficiency, and here the efficiency will directly relate to the amount of energy a product can provide you at the end of the process. So there are certain different types of plastics which are preferred for energy production and others are not. And in the coming slide, we will discuss about the different types of plastics which are suitable for energy production, some of them which are not suitable. What are those properties? Correct? So in this table, we can clearly see that PE and PP, they both are really good source of energy production via thermochemical pathway. I guess if you guys remember, only thermo processes are the ones which are utilized for energy production from the plastics. Other biological processes and those processes are not at all suitable for extracting energy from the plastic waste. The whole sole reason is because all the energy which is stored in the polythenes which you are extracting requires huge amount of energy, and biochemical processes won't allow you to give so much of energy in a process, right? So only thermochemical processes are there which will be suitable. So both PE and PP, they are very good source of energy. PS is also a good source of energy, and it's a very good source of fuel. We will discuss in the coming slides. ABS, it is a good source. You can use it. PVC, it's not at all suitable because at the end of the day, the energy which is extracted from it is less than the waste product which it is generating. PUR, again, same case like PVC. FRP is okay if you want to extract energy, but there are some pre-treatments or pre-processing steps which are in action to extract that energy. Again, following the path of PVC, PUR, PET is also not at all suitable for extracting. Now, here you can take a very broader look. For example, PET is not suitable for thermofuel generation, right? And in this slide, we knew that PET, the commonly occurring products are beverage bottle, jars, ropes, clothing, and carpet fiber, right? So a product which has no thermofuel efficiency or ability to generate, or at least we don't have the techniques to extract a really good amount of energy from here. And looking at the commodities, I'm sorry I'm going back and forth, but I want you guys to have a like broader look and understand why we have plastic management crisis. Because in PET, beverage bottles, everyone, as the summers are approaching, summers are already here. You guys know that beverage bottles will be hugely in demand. Even in the winters, we have water bottles and all those bottles, right? Medicine jars, so these will create waste. Why? We don't have any method to convert them into useful source, and yet they are available in abundant. Correct? So here comes this, that if we can extract energy from plastic, then why we have energy crisis? This is the reason. The type of plastic which is generating waste, we don't have technique or process, at least today or I don't know, in some far away labs, maybe researches are going on and you might be able to extract good amount of energy from this product also in the coming years. But right now, this is not the scene. So I hope that you guys are able to get the gravitas of the situation, that we have techniques, but it is not necessary that the techniques will be able to like clear all your problems and all your give you all of the energy solutions, right? Then this is just some basic statistics which is telling that in 2008 annual production of waste was basically 245 million metric ton. In 2008 we are not even able to comprehend such big number, right? And in 2014, like under 10 years, it increased 245 to 311 million metric tons. Such amount of plastic waste, out of which the chunks which are majorly contributing, we are not even able to use them to get energy back, right? So here is the role for you guys come in. You can give certain inputs, you can give certain ideas, you can have some really good projects, some really good research laboratories which are focusing here, right? So for you to understand that this is the problem, then only we will start thinking about the solutions. You can see here in the graph, right? And imagine this is a stats for 2014 and right now we are in 2023. So what do you guys think? This number will increase or decrease? Because simultaneously our technology is also increasing. So according to you, if I ask you right now, what do you think? The 2023 status, will it be similar increase in the plastic waste production, or will it be a bit declined increase in though it will increase, but will it be at this rate which we have seen from 2000 to 2014, or will it be a bit slow in comparison to 2008 to 2014? What do you guys think? Just something in the chat box will work for me. Increase heavily. Okay. Would you like to elaborate on it? You can either drop a text or unmute yourself. I will highly appreciate if you can unmute and talk to me so that I feel like that I'm talking to a person.
Hello, madam.
Yes.
Am I audible?
Yeah.
Fine, ma'am. At the 2014 to right now, there is a more usage of the plastic tattoo. The climatic situation handling, we are rectifying, but some then also the increasing need is there, so that the generation of waste also more.
Okay. But don't you think our techniques are also increasing with the same rate?
Yes, madam. It will increase, but the usage also rise.
Can it be directly linked to the increased population also?
Yes, ma'am, definitely.
Yeah. So this is one of the major reasons, because as the population is increasing, we need convenience, right? So convenience means if I'm somewhere else and I just want to have a glass, I just want to have a water or a beverage or a food or anything, it should be available to me right there and there itself. So for that, we need packaging material, we need carrying material, we need, for example, if it is related to cold or hot beverage, we need accordingly containers for it. So as the population will increase, the ability or the what to say, uh, the ability for a consumer to have everything on in their hand will also increase. This will lead to the more generation of products in comparison to the more generation of technology. So I also don't know what is the right answer for this, but I also feel like that it will increase either with the same speed or with increased speed. Yeah, so thank you for your input. Now, again, this is some of the statistics. It's basically with respect to India, because yes, we need to know where we stand in the world scenario. So here, can anyone brief me about this diagram? It is basically 80-20, very clear distinction. So what do you think? What is happening here? Anyone? If you remember the discussion, so it's basically around uh, 120,000 tons per day. This TPD is basically tons per day. So around 120,000 tons per day municipal waste is generated in India itself per day. Can you imagine? And that municipal waste has 80% PP, PE, PS, PET, and PVC. Again, remember PET, PVC. These are the ones which are not suitable for energy production, right? And the 20% belongs to ABS, PC, and other types. Correct. So this is a huge problem for us. We are generating so much of municipal waste, and this is not at all diverse. The major chunk is distributed and present in the type of plastic, or it has that type of plastic for which we don't have enough technology or enough techniques, right? So it is not a good situation. So following this, don't be sad. Things are happening. People are working in this direction, and we might see some positive results in the coming years. So I have till now, I guess I've made myself very clear that we are in dire need of really good plastic waste management, as well as uh, generation energy from the waste. So these are some of the points resembling that information only. So in India, waste plastic forms widespread littering on the landscape due to the lack of proper management techniques. And I don't think I need to explain this point. Every one of you knows this. Second, around 8 million tons of plastic waste was dumped in the ocean each year, right? Because we don't have enough land space to hold such plastic. So we are dumping these things in the ocean. If you remember, in the last few years, I guess, I don't remember the exact timeline for it, but there was a time when everything was coming to the shores. Anyone remember this? That whatever was there in the ocean, like the big containers, small containers, water bottles, uh, uh, small plastics which get wrapped around other things, right? The container films. Those things were getting accumulated in the shores. I don't know from which place it was, but because the quantity is so much in the ocean that even the ocean is not able to take it in, right? So it is a very bad situation. Then, why it is a bad situation? Because plastics are contradict me in this point, this one, that the plastics are not biodegradable. What is a biodegradable commodity? What is
which yes, which
biodegradation?
yes, ma'am. Micro due to microorganism growth, the whatever the material which will degrade, and that are all is biodegradable. So hello. So sorry, ma'am. I think we have a network problem also. I'll text him.
Mm-hmm. Microbes are here. Yeah, please do take.
Yes.
Other people are also welcomed to just drop in the text what is biodegradable or biodegradation, and is plastic a biodegradable commodity or a non-biodegradable commodity? Anyone? So non-biodegradable commodity. But if you are bit into the field of biodegradation related to plastic, yes, Venkatesan, yes, you are correct. So, what are your thoughts on plastic being non-biodegradable? I I am pro that plastics are non-biodegradable, but we have seen, at least in the at the lab scale, there are certain microbes or synthetically generated microbes or genetically modified microbes which are able to degrade plastic, right? I think you guys might have heard news about that. Okay, scientists have found a microorganism which is able to eat plastic or digest plastic, right? So these are all at the lab scale level. We have modified organisms in such a way that they are able to eat out this plastic. So why we are still calling it a non-biodegradable commodity? Because the first of all, it is in a lab setting proven concept, right? We don't know what will happen if we took it to the uh, scale at which the problem is currently happening. Second, the rate at which these microbes are digesting these products or plastics specifically is not that high, at least in the current scenario, right? So even though they are able to digest it, but they are not able to digest it at a rate in which it will be significant for us to start seeing difference in the landfill, because it won't happen naturally until unless we are putting these organisms into the wild, correct? Hence, till now, even till today, the plastic is categorized into non-biodegradable commodity. Next, in spite of the above facts, due to user-friendly nature, ban of plastic could not succeed in India, right? In our lifetime till now, we have seen so many news that okay, now from now on or from first of any month, the plastics will be banned. But they are not able to ban it because why they occur in so much diversity and in so many numbers, because they are very useful, right? When they first arrived, they were very handy for us. And hence now we are not able to go back to the days where there was no plastic at all. Hence, banning them is not a solution, right? Recycling and reuse of waste plastic is highly necessary. It is necessary, but how many of us, even like we are here, we are studying about it, we know things about it. How many of us are actually doing recycling, right? We are aware of the concept, but we don't know how to proceed first, or second, maybe we are not even doing it consciously. Last but not the least, pyrolysis is a cost effective process and is applied for waste tire management and being investigated for using waste plastic. As I mentioned, thermoprocesses will be the one by which energy can be extracted from the plastics. So pyrolysis, I hope you guys remember, as we have covered the pyrolysis and the extent of different types of pyrolyzers, the products of pyrolysis, all those things in quite detail. Next, options for management of plastic waste. So these are some of the basic plastic management waste options. Can anyone brief me what were they exactly? What was primary recycling, secondary recycling, and tertiary recycling? Anyone?
Madam, in primary recycling,
Yeah.
we are recycling to the same original product. From the beginning, whatever we are carry back and we are recycling, the
Mm-hmm.
same only will produce. Right, man?
Okay. Hmm.
And
Yeah, yeah,
second, yes, in the secondary, we are converting it to different form. So I heard that some plastic bottles and all they're recycling and they'll make us a class. So it was
yeah.
completely
Yes.
different product. And
Yeah, yeah, correct.
yes, in tertiary recycling, we are converting it to chemicals. Like if polyethylene, if we are using, we are extracting ethylene from that. So completely different form.
Hmm.
It's a chemical use only. We are going to. And next,
Yeah.
and we can use it for the fuels also. And during
Hmm.
qu- quaternary recycling, we are retrieving energy. So by the use of pyrolysis, we'll get
Hmm.
some fuel gases and we'll retrieve the energy from that.
Yeah, correct, correct. So as Venkatesan rightly mentioned, the different types of recycling. I hope you guys are able to follow him. So it was basically that primary recycling is taking the product and then using it for converting it for the similar purposes as the original product. Secondary, it's basically somewhat different characteristics from the original product, but still it will be a plastic use product only. In tertiary, it is converted to some basic chemicals which are in high demand because in laboratories, in industries, we use chemicals, right? A very basic example will be, for example, not necessarily from the plastic waste, but I guess everyone is aware of the acetone, right? What acetone is used both in laboratories or R&D labs. Generally, girls uses for removing their nail polish, nail removers, right? They're basically alcohols in nature. So if we have plastics and we can extract some important chemical from it, it will be called tertiary recycling. Quaternary recycling will be for retrieving the energy content from the plastic waste. And as you can see, this is not used in India. Can anyone tell me why it is not used in India? Any reason which you can think of? Even if it is wrong, don't worry about these discussions will help you in understanding the concept. We are just saying it is not used in India. But according to you, what are the reasons why? Because India is a very big country, right? And we are growing at such a high pace. So why we are not able to do quaternary recycling? And we are facing that we don't have any plastic management issues as we have discussed earlier.
Economic, economic feasibility, madam.
Venkatesan, I think you are traveling or something because your voice is breaking. Can you drop a text in the chat box? Economic feasibility. Uh, but see, we have incineration plants, we have pyrolyzing plants, and these are the processes which are used in quaternary recycling. So why we are not using it? this reason is correct, but I want you to question yourself, because what are the processes required in quaternary recycling? It is pyrolysis, right? As you rightly mentioned earlier. But we have spiralizing plants. Then why we are using plastic for and subjecting it to pyrolyzer? I would like you all to go back and think on this and are you guys able to hear me? Can you guys see my can you guys see my slides? Because I think there was a brief disconnection. Okay, cool. So what I was discussing here, that there are number of processes that have been developed worldwide, mostly by using pyrolysis. Some small and medium scale plants are operative in India and other countries, but these do not have wide acceptability. So your reason saying that it is economically feasible, I mean not feasible economically, it is one reason because we have medium and small scale industry, not large scale industry. The other thing is that these are not widely acceptable. It is primarily because of the some attached notion to such things. I would like you guys to dig on it a bit more, and if you can just sit and think about this, that we have a technology, right? It is not a technological issue. It is not a technique related problem. We have raw material that is waste, plastic waste. So it is not an issue of plastic waste. Then still we don't have bigger industries for this. What are the possible and probable reasons? This is the basic question I want you to pyrolysis. I hope that you guys remember that the which were discussed in the class, and you guys need to remember this formula. It's pretty easy, very generic formula, right? For efficiency of yield and then reaction mechanism here, because I think that most of you are from chemical engineering background, so you might have some of the idea what is happening here. So can anyone brief me, or at least just tell me the basic steps involved in this process or polymerizing process? No problem, Manchu. We will discuss it. And if you are not, go back and look at the lectures. If you are telling me this for the reaction mechanism question and not for the question which I asked earlier. Yeah. So breaking polymer into monomer. Okay. Then this is the first step called the initiation step. In initiation, you have raw material, which is generally a plastic or a carbohydrate, long chain of carbohydrate. You subject it to some heat, it will get converted into free radicals, right? Then propagation step. Free radicals, as many of you might know, that they are very highly reactive, right? So they will come in contact with other free radicals and they will simultaneously and very quickly polymerize. And they will also make other or get involved with other compounds, and this will saturate them. What is saturation or unsaturation? If you remember, single bond, double bond, triple bond, right? Fully saturated carbohydrate will have how many double or triple bonds? My question is, a fully saturated carbohydrate will have how many double or triple bonds? One triple bond, two double bond. Are you sure, Venkatesan? I'm asking about saturated product. See, saturated product means it will have zero double or triple bond. Remember? Saturation means there is no double or single bond. Unsaturation means that the compound is having either a double or a triple bond or both. Right? So it will generate unsaturated products also. There will be hydrogen transfer. That hydrogen transfer is due to the formation of a free radical in the compound itself. And for those who are not getting these reactions, I will suggest you to go back to the Professor Mandal lecture, listen those lectures, then go back to some of the sources which are provided to you, read about it. If you're not getting it, you can ask tomorrow also, because there will be, I hope you guys remember that there will be a discussion class tomorrow also, right? And even then, if you're not able to get it, just drop a query to me. I will try to help you out. Correct? So the one of the important step in the reaction mechanism for this process is beta session. Beta session can, do you guys remember what was beta session, or what are in this compound, this one? This is 1, 2, 3, 4, 5, 6, 7, right? Third one is the free radical carbon. Can you tell me which one are the alpha carbon and beta carbons? In the lecture, if I remember, it was discussed. But if you do not remember, don't worry. Right? If you see at the products, so beta station means basically that it will size at the beta place. Here it will be one compound, which will be, if this free radical is shifted here, so this will be one compound and this is the free radical. If it is shifted towards right, then this will be the one compound and this will be the free radical at this point, right? So some reaction mechanisms which will happen when you will subject plastics to pyrolysis product, right? So basically, as I said, that there are two different types of pyrolysis. One was thermal pyrolysis and the other was catalytic pyrolysis. So thermal pyrolysis, you guys have covered in the previous lectures, right? We have discussed it very extensively also. We have discussed the basic theme of pyrolysis, different types of pyrolyzers, what are the products made in pyrolysis, and on what factors the products are dependent upon, right? So in thermal pyrolysis, process generally involves operation at high temperature around 350 to 900 degrees Celsius. Formation of liquid products have wide distribution of carbon numbers, which will in the end help us in generating fuel such as diesel, right? Then catalytic pyrolysis. So in the catalytic pyrolysis, process reduces reaction temperature and reaction time. Now here I want your active participation. What is catalysis exactly? Irrespective of whether it is in waste product or anywhere else, what exactly is a catalyst? Say not catalysis, but what exactly is a catalyst? A substance which speeds up the process. Why we need to speed up a process? If it is, for example, a process is happening at, it requires, say, 400 degrees Celsius. It's a pyrolysis process, for example. It requires 400 degrees Celsius, right? So it is happening at 400 degrees Celsius. Why we need catalyst for it? Catalyst will also do the same thing, right? So if we already have 400 degrees Celsius temperature and the process is happening, why we need extra commodity? One big reason why we use catalyst. Your answer is not wrong. It is right. If we are talking about basic catalyst or catalysis. See, here we are saying that pyrolysis is occurring at high temperature around 350 to 900 degrees Celsius, right? From where are you generating this 900 degrees Celsius? It might be from some external source, right? But what if we have a substance, if we use it with our raw material, the same process can take place at 400 degrees Celsius, which was earlier happening at 900 degrees Celsius. Are you getting my point? It will help the product, it will help the raw material, here the plastic, to get processed at a reduced temperature, because a thing which was happening at 900 degrees Celsius, for us to reach 900 degrees Celsius, it is a tedious task. So if we can take some measures through which the same process can occur, but it can go below the temperature which was earlier required, right? So how it will, basically it does it? If you guys remember enzyme kinetics or enzyme mechanism, though it is not related to this. So this is the basic principle of catalyst, that what it will do, it will reduce the temperature which is required for the process, right? Hence, we can do the same process at a reduced temperature. Because if you increase temperature, apart from the problem that from where are you getting this high temperature, we don't have such material which is able to hold extended duration of high temperatures, right? We need to think in all directions. For example, you are able to reach up to 7,000 degrees Celsius, right? But you don't have a metal or a container or a material which is able to hold that temperature for a half hour, correct? So this will make our process slow. I hope I'm making sense. Am I clear? Uh, are you guys able to understand what I'm saying, or I'm trying to convince you guys for? Okay, great. So one of the best qualities of catalytic pyrolysis is it reduces the reaction temperature and reaction time. The quality of the liquid product obtained is better. It helps in narrow down the product distribution of carbon number to gasoline and diesel range. This you will um, Himanshu, what exactly is bothering you? what are your doubts? Like, I'm here. You can text me in the chat box and I will try to help you out. And if you are from the chemical or chemistry background, then I think it might be a bit clear to you. And if you are not, then I have to explain it to you in different ways. So just drop your query and I will help you out surely. Okay. Yeah. So this is basically efficiency from the pyrolysis of plastic. So product at 425 degrees Celsius from real waste plastic. You guys, because now you are pretty well versed with what is a waste, what is a batch reactor, right? We are talking about a product yield at 425 degrees Celsius, right? So raw material temperature from thermal pyrolysis in which there was no catalyst used at four. Okay, there was disconnection. You guys able to see my slides or was it only disconnected from my side? Okay, I hope that you guys are able to hear me and see my slides. So I was discussing about the products and their yield. Sorry, so the gaseous products at normal thermal pyrolysis, only around 8% of the product was giving yield. 8% yield was available for gaseous product. While if we were using catalytic pyrolysis, in which a catalyst is used, it was up to around 10%. It is definitely above normal thermal pyrolyzer. While tar and calcium oxides were higher in thermal pyrolysis and they were low in catalytic pyrolysis. So is it a good thing or a bad thing that the char is low in the catalytic pyrolyzer? Is it advantageous? Is it an advantage or a disadvantage? What do you guys think? It's a disadvantage that we have low char and calcium oxide. Anyone else want to pitch in? Uh, okay. What? Why it's a disadvantage? Himanshu, first you need to tell me what you think. Is it a disadvantage or an advantage? Because right now, according to Divyansh, having low char is a disadvantage, and according to Venkatesan, it is a I guess no means it's a advantage, I hope. So first we need to be clear whether it's an advantage or disadvantage. And if it is an advantage, then why it is an advantage? And if it is a disadvantage, then why it is a disadvantage. So having low char, which is a characteristic, or you can say which is available in the catalytic pyrolysis, is an advantage. Why it is an advantage? Because char doesn't give us any energetically favorable product. It's like a waste, right? We need to handle the waste. Now we need to find a place to dump it, or we need to try certain operations in which char can be used. It has no, like, very less to negligible energy value. It is not a high energy value commodity. Hence, having low char, okay, okay, no problem, Manshu. I think now you might be able to understand having low char is the advantage, because then char is like a waste that you have extracted all the energy from a commodity, and what is left will be char. So char has zero or very less energy profile. So lower the char, better the energy commodities in which your product has been formed. Meaning, if there is less char, which means most of the energy which was stored in the products have energy from the raw material, right? So there are, again, these are very basic terminologies which we are studying since our first week of class: batch mode, continuous flow mode, fixed bed, fluidized bed, right? So these are same, they have, as I mentioned earlier also, that most of the things have similar principle, but they are applied in different unit operations, but their principle will stay the same. So what exactly is the catalytic pyrolysis? I hope you guys now have bit of idea that what is a catalytic pyrolysis. So there are two kinds of decomposition mechanisms work, right? First is thermal cracking, second is catalytic cracking. The catalyst can promote, again, these are the benefits of having a catalytic pyrolysis or a catalyst in the pyrolyzer. It increase the process selectivity because catalysts are selective in nature. Decomposition reaction at low temperature with lower energy consumption. Again, because you are lowering the temperature, hence energy consumption will be low. Reduced cost because you are lowering the energy consumption. Liquid products with a lower boiling point range. This is the benefit of a catalyst. So these are some of the basic things related to catalytic pyrolysis. I will like you guys to go back to the lecture once and directly go through the slide so that things can be pretty generic. Waste specific for plastic segregation techniques might change for plastic waste or for agricultural waste or for municipal waste, but the operation will always be called collection and segregation, right? So you can use them as a generic steps apart from where the energy processes start. For example, from here, this will be pretty specific for plastic waste, and above ones will be specific to any particular waste. Okay. So I hope that you guys were able to remember what was covered in the week 5 lecture. Now, as usual, we will go back to some of the previous year questions, which might help you in solving your current problem. So, as someone asked me about my intro, I have already given in the beginning of the class. My name is Himanshu Singh. I am a PhD candidate here at IIT Kanpur in BSB department. So now we will look at some of the questions, right? And I will like at least participation from everyone. Okay, even if it is wrong, I will appreciate if you guys are taking part in the discussion. Cool. Yeah. So let's go and start with the first question. The plastic material used for manufacturing of beverage bottles, medicine jars, rope, clothing, and carpet fiber is mostly LDPE, PET, HDPE, or PVC. We have discussed it today. So I hope most of you guys will be able to answer it. right? As like there is, I guess, some issue with the internet disconnections. Mhm. Am I clear now? Hello? Ah, okay. Thank you, Manshu. So, okay. In the following process, the components A and B are. We haven't discussed it today, but it was part of the or part of this week lecture, and it was associated with, say, extraction or something. I'm just giving you guys some hint. So, what are the components A and component B in this flow diagram? In this flow diagram, basically, what is happening? A fuel is entering, then it is passing through a turbine, and again it is passing through a B component, then A component, and again to a boiler where fuel is injected. So I have received some answer. We will see what is the right uh, answer. More uh, answers or at least attempts. I know things are maybe moving at a faster rate, but we are approaching the end of the course. I think you guys have 7th week lectures with you, right? So I think you guys are way ahead of me. Okay, so the answer is pump and condenser. Yes, Divyansh, you were correct. And if you remember from where it was associated, from where we studied this diagram. Otherwise, the moment I will show you the slide, you will remember it, right? So we studied it in the types of turbine and cycles for power generation from plastic. So it was discussed here. You guys can go back to the lectures. And if you have some doubt, you can ask tomorrow, as well as you can drop a mail or anything. You can go to my site. As you have seen, I have provided the link, and I will try to clear all your queries as soon as possible. But first, if you're sending me a query or to anyone, it is expected that you have gone through the lecture, you have referred to the reference, and then also you are having problem, right? But still, you can reach me at any time. Next question. It's a pretty direct question. So if you remember it, it is really good. And if not, then don't worry. You can always go back to the lectures. So in this question, what exactly is asking? So energy loss due to convection and radiation from boiler, surface and steam process can be given by. So if you remember it, really good. If not, don't worry. I will jog your memory by showing you the slide. So any takers for this question? Anyone attempting even to at least try to attempt this question? No one? Okay, no worries. I know it's bit, it was the answer is HC plus HR. As you can see, the HC is basically convection heat transfer coefficient. HR is radiation heat transfer coefficient. AS is the total surface area which is exposed, and TW is the temperature of the surface of the wall. So here, why we were talking about the losses, because if you have a process, for you to know what exactly is the energy generation, you need to know the input energy and the energy lost, and then you will know what exactly was the energy you are taking out from the system or taking out from the commodity, right? Next question. Which of the following separation techniques can remove particles of size greater than 0.01 more efficiently? Is it cyclone separator, filter fabric separator, gravity settler, or ESP? I need more participation. You guys can even attempt wrong answers. It's okay, but at least try to attempt these questions. Okay. Any more attempts? Okay. The answer is fabric filter. So even if you do not remember, I might help you in remembering. This was the or they here particle separators, where you can actually separate particles of this particular range, right? So this was the USP or the speciality of fabric filters, that they are the one with highest efficiency, at least for the things which, in comparison to the things which we have now. So our next question is, which of the following chemical can be used for physical absorption for gas cleanup? Is it Flexol, MDEA, Selexol, or diethanol amine? Any guesses? Okay. Just a hint that we have discussed the same compound somewhere else also. Not particularly in week 5, but before week 5, we have discussed it. So, yeah. Okay, I have few answers. Other people, you can also participate. Like I can see people here. Just try to attempt these questions. These will help you in clearing your current affairs uh, you won't be needed to sit for longer hours for specifically prepare for this courses and attend not need separate particularly for this subject for clearing the exam. Okay, the answer is Selexol. We have discussed it, and even in the this absorption process only. But don't worry if you do not remember it. I know there are so many things which you guys are jumbling right now with the amount of information which you guys are getting. Back to the will technologies, and next the follow is not everyone's Are you guys able to hear me? I'm so sorry for the Wi-Fi problem. I don't know why it is happening today. You guys able to see my screen? Hello? Hello. Um, I assume that my slides are visible and I am audible. So my we will try to wrap it up early today because I don't think my Wi-Fi connection is stable and my data is also not working properly. So we will try to wrap up questions bit early today. Uh, so which of the following statement is not true about catalytic pyrolysis? So processes operate first optional processes or process operates at low temperature than thermal pyrolysis. It requires high residence time than thermal pyrolysis. The quality of liquid product is better. The product distribution of carbon number is in the range of gasoline and diesel. Uh, Thank you, Divyansh, for sending me the answer because before this, I was thinking that I'm not audible or my slide. Thank you so much. Yeah, so the correct answer is B. It requires high residence time than thermal pyrolysis, as we discussed it today itself. That one of the quality of catalytic pyrolysis is that it will reduce the temperature and reduce the retention time, right? Then the next question. The name of the following pyrolysis reactor is, so is it a screw reactor, a canonical spouted bed reactor, a fluidized bed reactor, or a fixed bed reactor? If you remember, do type your answers in the chat box. Okay, the answer is canonical spouted bed reactor. It can't be a screw reactor because we cannot see any screw. And if you have some confusion, I would highly suggest you to go back to the slides. So this was the figure which was associated with the canonical spouted bed reactor. And even if you do not know the exact diagram, just try to connect the terminology with the structure which you are seeing, right? At canonical spouted bed reactor. Spouted means a narrow opening. Canonical means like sorry, not canonical. I'm so sorry. It's a conical. Canonical type or conical structure, which means basically a cone-like structure. I'm sorry, wherever I said canonical, it is conical spouted bed reactor. Then upcoming 8th, 9th, and 10th, these questions are numerical type questions, and I will give you each for each question, I'll give you 5 minutes to first try and attempt these questions, and then we'll discuss the solution. So the first question is, in a laboratory, 55 gram of plastic waste is pyrolyzed in a batch reactor weighing 750 gram. Weight of collected oil is 37 gram and final weight of the reactor is 755 gram. The yield of the gas, liquid and solid fractions are. It is a very generic question. You do not need to remember the formula, but for your A's, I have put the formula here. Your 5 minutes starts now. Just try to attempt the question and send your answers in the chat box. Yes, Divya, we will see what is the answer. Uh, you guys still have 1 minute left. So anyone who wants to send their answers in, you can still send them. And then we'll discuss the solution. Oh, I'm so sorry. I hope that the solution is bit clear to you guys. For liquid person, you can directly put the weight of the liquid, which is given as 37, the weight of the feed, which is 55, and you can get the answer. For the solid, you can get the same formula. You can put the same formula, but here, one trick is, you know the initial weight, you know the final weight. You need to take the difference of the weight which is actually used and then calculate the solid fraction. For gases fraction, you can directly subtract because it is 100%, right? The percentage means. So you can directly subtract the summation of both liquid and solid from the 100, and then you can get the gas fraction from for this particular type of questions. Now, question number 9 and next question. They both are related question, but you don't need to worry about it. I will display the formula for them, and I hope that you will be able to solve them. So our next question is, municipal solid waste based power plant is emitting 50,000 meter cube per hour flue gas. It is proposed to install an ESP with a collection efficiency of 96%. Calculate the total area of the collection electrode, and the drift velocity is given. Um, okay, so this is the formula even for the previous question. There is some change in the animation flow. So this is the formula. Just write it down in your sheets or wherever you are writing. I'll give you 1 minute for this, and then we'll go back to the previous question to look at the given quantities which we have to manipulate this formula and get the right answer for ninth question. I hope you guys have written it. Now, yeah. So now by using that formula, try to put the values which are given here and try to get the answer. You do not need any other formula for such questions. You need the formula which I hope that most of you have noted down. So I'll give you 5 minutes for it, and your time starts now. I hope most of you have tried, but even if not, don't take stress about it, because if you go back to the lectures, these concepts were, or these types of questions were solved in the lecture itself. So the answer is basically 298, and we will see how we know it comes like 298. Basically, the formula which I have told you, I think most of you might not remember what these variables stand for. So it's basically flow rate, if you remember from the session. Flow rate is always calculated in this case because the drift velocity is given in the units of meter per second. So you need to convert the flow rate also in the meter cube per second, which is given in meter cube per hour, right? So you can just directly divide it by 3600 to convert it into second. As I mentioned, this is the efficiency of it. So your VPM is basically the drift velocity, AC is your area, and Q is your flow rate. And efficiency is given like 96% or 0.96. So if you put these values, and if you do not know how to calculate the exponents or E types operations, you can search some of the YouTube videos. There are some basic maths are given there, but I assume that most of you are from engineering backgrounds, so you won't be having any trouble in solving such type of numerical problems, right? So if for solving this is the basic type of operation which you perform on E value types variables. And then if you solve it, you will directly get the area, which is 298 meters square. Again, if you have any doubt, I will highly suggest you to attend tomorrow's session and clear all your doubts then and there. Then coming to the last question, as I mentioned that these both of these questions are connected. So the values which you have obtained in your ninth question will be used in your 10th question, right? So what it says that in the question 9, what would be the additional collection electrode area would be needed if the collection efficiency is 99.6%, right? So the value which you need from the previous question is of drift velocity, right? Because at the end of the day, we're going to use the similar or the same formula. For this formula, you need to calculate the area. Q you have from the previous question. VPM also you have from the previous question. The only thing which is changed here is your efficiency, right? All the solution which you have seen here, it is similar to it. It's just there is one change in the efficiency value. So I'm putting this formula here. I'm giving you guys four, 4 to 5 minutes because it is almost, or I will say exactly the identical question, except some change in the value. Try to attempt it and type your answers in the chat box. Anyone of you have tried it? Just send your answers in the chat box. I think we do not need more time in this. It is, as I mentioned earlier, that it is exactly the same question, except there's change in the efficiency percentage. And Divya, yes, your answer is correct. So the solution is also identical, as I mentioned, that Q is given, and you have seen from the previous question. We have the formula of efficiency. We just need to input our values like the previous question, except at this point, the change will be for the efficiency. Earlier, we were putting 96%. Here we are putting 99.6%, right? Everything else is same, and you will get the cross-sectional area or the area of the electrode at the end of the day. And if you are not able to get the solutions like this, go back to the lectures, try to understand the concepts, the variable, what it means, try to solve them by yourself. There are plenty of examples in the lecture. If you're not able to get these, try to attend tomorrow's discussion session. Even then, if you have doubts or problems, you can contact me. So, and I apologize for all the inconvenience caused due to my Wi-Fi. It won't happen again. And this is all from my side. And thank you for your patience. I hope to see you again in the next class. Thank you. If you guys want to leave, you can leave.